Air-Propelled Rocket Experiment by Dylan Crosshauer, Sami Usainovich, and Dallas Watson.
Parts of a rocket launcher. The rocket and its launcher are composed of four main components: a pump with a launch cord, air transfer line, air reservoir and a launch pad, and the rocket.
The pump with launch cord consists of a high-pressure fuel pump and a hand-release launch cord that launches the rocket. The air transfer line receives the air from the high-pressure floor pump and sends it into the launch pad.
The air reservoir with launch pad houses the air created by the high-pressure fuel pump and is the mount for the rocket. The projectile is the rocket which launches into the air.
Safety procedures. When launching the rocket, there are a few safety procedures that should be followed. You must wear glasses, launch the rocket in a wide open area, and never point the rocket in the direction of a person.
Safety goggles should be worn to prevent from the hazard of the air reservoir shattering and having fragments shot into your eyes. You should also avoid launching the rocket in heavily used roads and areas that have power lines. The ideal location for launching a rocket would be in a wide open area that is not in use.
Never point a rocket in the direction of any person and only launch it upwards. Rockets are something not to mess around with, and some of them reach speeds that are extremely dangerous. These high speeds can cause great bodily harm, and because of this, they should only be shot upwards.
Video of the rocket launch. Our frame of reference was low on the ground, so we could do the projectile throughout its full course of travel without having to move the camera. In order to set the scale, we measured a mailbox post. You can see it on the right side of the video.
While watching the video, did you notice that the rocket left a trail that appeared to be smoke? In all actuality, this was not actually smoke. In fact, it was actually condensed water vapor. This condensed water vapor is known as a contrail. You can often see these contrails in airplanes in the sky. Due to the fact that these contrails appeared in the video, it also made it easier for us to mark points using Logger Pro. Let's watch this video once again and try to spot the contrail.
In our Logger Pro analysis, we plotted dots frame by frame in order to generate graphs related to the information. Our x-axis had time in seconds, and our y-axis had position in meters. We went on to create position and velocity graphs with the information on both axes.
The following is a position versus time graph based on the y-axis, which is position in meters. As you can see, a parabola is created because the rocket went up in the air and made its way back down to the ground. At the middle of the graph is where the rocket reached its highest point. We also created a line of best fit and discovered a quartic equation best suited this data.
The following is a velocity versus time graph based on the y-axis, which is position in meters. As you can see, when the rocket began to launch, it started off in a positive value, but as time progressed, the rocket made a gradual decrease into the negative range of values. We also created a line of best fit for this data using Logger Pro software, and we discovered that a linear equation fit this data best.
This is our position versus time graph using the x-axis, which is time. As time increases, so does the position of the rocket, until the end of the time, which then the rocket begins to gradually decrease as it falls back to Earth.
Newton's first law of motion states that an object remains at rest or motion until acted upon by another force. The rocket relates to the first law of motion because when the rocket was on the launch pad, its forces were balanced, but once the rocket launched, the air pressure caused those rockets to be unbalanced, which results in the rocket launching into the air.
Relation to Newton's second law of physics. Acceleration is produced when a force acts upon a mass. The greater mass, the greater amount of force needed to accelerate the object. The rocket relates to Newton's second law of physics because in order for the rocket to launch high enough into the air, the rocket must use a large amount of fuel to give it its initial thrust so that it reaches its greatest action force early in travel.
The third law. Every action has an equal and opposite reaction. The rocket relates to Newton's third law of physics because in order for the rocket to launch, it must expel gas, which in this case is air, from the bottom of the rocket, in which the rocket pushes on the gas, and the gas pushes on the rocket, resulting in it launching into the air.
During this project, a difficulty we faced was finding the best frame of reference so we could record the rocket throughout its travel. We also felt that this project was a very valuable experience because we got the opportunity to learn the physics involved with launching a rocket.